This is the chromatography lab where I'm going to separate black ink into its components. So black ink is a mixture, and I have a variety of black ink pens, different brands, different types, different sizes. And I'm going to try to find out if the black ink in these pens is a mixture or a pure substance. I'm going to try to separate, if it is a mixture, I'm going to try to separate out the different components or the different inks within the black ink that make up the black ink, and also try to use that information to identify an unknown. So in order to do this, we're going to do paper chromatography. Paper chromatography uses a piece of paper as the stationary phase, and then some kind of chromatography solution as the mobile phase. Chromatography works by having the mixture placed on a stationary phase, and then have a mobile phase pass through the stationary phase, and then different components of the mixture will move at different rates along the stationary phase. So some of the dyes will be more attracted to the paper and they'll move slowly. Others will be more attracted to the liquid, the mobile phase, and they'll move further along in the paper. So to do this, we're taking a paper, cut it into a rectangle. We're going to draw a line using pencil, 1 centimeter from the bottom. And then we're going to put dots from our 8 different pens. We'll label this A through H. So I'm setting up my paper like this. It's chromatography paper labeled A through H so that I can use a mark from each of my pens. And now I'll just take the pens, and they're just different types of black ink markers. And I'm just going to put a very small dot with each marker in front of each of the letter, above each of the letters. I have this pencil line to measure or to mark where each of the dyes is starting from, because later I'm going to measure how far each of the components travels. So just a very small dot. You don't want a lot of ink, or you don't want a big dot. You just want a small concentrated amount of ink right along the pencil line. So we have eight different markers, and each of these markers is going to have a different type of ink in it, most of which are made up of a mixture of other dyes. So here I have my chromatography paper. It's set up, ready to go. It has 8 different markers. They're labeled in pencil so that the pencil lines don't wash away as we do the chromatography. When you do chromatography, this is the stationary phase, so this ink is stationary. It's still on this paper. And then I have a mobile phase. The mobile phase I'm going to use here, this one is going to be acetic acid, which I'll show you first. And acetic acid will move up the paper, and it will take some of the dyes along with it. So I'm going to put this into my chromatography solution, and you can see that as the mobile phase, the acetic acid starts to move its way up the paper, you're going to see that the inks will start to travel with it. And so you'll see that as the dots starting to get larger. And over time, if we let this go for a few minutes, you'll see that the ink spots will actually start to separate out. So some of the ink will travel faster than others, and the black ink is actually a mixture of several different colors, maybe red, and blue, and yellow. And if we separate it out over time, we'll see that some of the inks travel faster and others more slowly. So we'll set this aside. You can see it's starting to happen. You can see that the inks are starting to move up the paper. And as this takes place, which you'll see in a few minutes, here's one that I did a little bit earlier. So this was put in the acetic acid and left for about 5 minutes. And you can see that now each of the ink spots has moved up and spread out, and you can see the different components that it was made up of. If we look at ink B is a good example right here. You can see that ink B was split into kind of an orange ink, a purple ink, and a blue ink up here at the top. So the black ink spot that was down here at the bottom spread out into these 3 different colors. The orange traveled kind of slowly because it was more attracted to the stationary phase, the paper, and the blue ink moved a lot more quickly. It was more attracted to the mobile phase, which was the acetic acid in this case. And you can see that each of the inks was different, and you can see that it spread out in a different way. Spread out into different colors, maybe black and purple. Here we have with G, you have some yellow, some red, and some blue. F didn't move at all, so F was completely attracted to the paper and didn't move at all along with the mobile phase. What we're going to do next is calculate the RF values. So that stands for ratio to the front. It's a ratio of how far the solvent moved, so how far did the acetic acid move up the paper, compared to how far each of the dyes moved. So in order to measure this, you're going to measure from the pencil line all the way up to the top of the mobile phase. So the top of the mobile phase was right up to here. And so what I would recommend is that you push pause on the video and that you measure with a ruler from this line all the way up to the top of the page right here. That's how far the mobile phase moved. And we're going to compare that to how far each of the dyes moved. So for instance, this orange dye right here, we'll kind of estimate the middle of that orange dye. And what I want you to do is measure from the pencil line to the middle of that orange dye right there. And you're going to get the ratio from the pencil line to the middle of the orange dye divided by from the pencil line all the way up to the top of the mobile phase. So if you're viewing this on your computer screen, it doesn't matter how big it is, you can measure with a ruler and the ratio will stay the same no matter what the size of your screen is, but you're looking at the ratio between how far the acetic acid traveled from the bottom of the pencil line up to the top compared to how far each of the inks moved. Each of the inks moved kind of not to one spot, but to a variety of spots. So you have to kind of estimate the middle of the orange, and then we'll measure one to the middle of the purple. So from the line to the middle of the purple is about here, and then from the line up to the middle of the blue. And so you'll have three different RF values for this ink B, going to the middle of the orange, the middle of the purple, and then the middle of the blue. And you'll repeat that for all 8 of the inks. Each of the inks split up into 1, 2, or 3 colors. So however many colors you see, you write down that many, or you calculate that many different RF values. If we use a different chromatography solution, you'll see slightly different results. So this was done with acetic acid. This one was done with ammonia. And you'll see that the one done with ammonia is not exactly the same. You'll see that some of the dyes moved more quickly with ammonia, some of them not as quickly. So for instance, the dye F didn't move at all with the acetic acid. It stayed just in one spot. And with the ammonia, it actually did travel with the mobile phase up about, I don't know, 1/3 of the distance that the ammonia moved. If we use a totally different, another different one, so you might want to pause it right now, and you can measure for the ammonia, and you get all of your RF values for the ammonia. And then I'll move in another one. This one was acetone, so a different type of solvent. This one's a little harder to see, it's not quite as dark, but there's some interesting things here. If you look, for example, at G in the ammonia, that dye, the blue section moved really far, the yellow and the red not as far. Well, if you look at when we used acetone as our solvent in G, you can only see the blue right here, so the blue moved hardly at all, and yet the red and the yellow dyes moved a lot further. So it's almost the opposite with the acetone as you saw with the ammonia. And so you're able to calculate RF values for this as well. You're going to get different RF values depending upon what your mobile and stationary phases are. All right, and then the last part of this lab is to try to identify an unknown. So here's an unknown. It's one of the inks that we've already looked at. And here it is treated with acetic acid. And that's what it came out looking like. And so you can measure the RF values for this dye and compare it to the known solutions. And then here is the same unknown treated with acetone. And so by looking at those, they should look like one of the unknowns, and that will help you to identify which one it was.